Hello everyone. Today I am Rishabh Bhardwaj, Assistant Professor from the Mechanical Department, taking the lecture series of heat transfer. Today in this lecture we will study about the journal heat conduction equation in Cartesian coordinate. Let's start with the with one question that is, what is the basic form of heat conduction equation? And its answer will be the basic form of heat conduction equation is observed by applying the first law of thermodynamics, that says or that are based upon the principle of conservation of energy, which says that energy neither be created and nor be destroyed, only it can transfer from one body to another or changes into one category to the another category, but it does not deform. On the basis of that, in the Cartesian coordinate, in the three dimensions, we have to study about the transfer of energy, that is a thermal energy, that is heat. Let's take an example. In this figure we have a cube or a cuboid in which lies in a three dimension, that is a x, y and z. From the x direction, from the left side, qx heat is entered in a cube and it is rejecting or transferring outside from the right hand side, which says that the complete q or the heat plus the change of heat, either the heat is get reduced or the heat may be increased. So we have mentioned it as qx plus dx, and dx is the variation of the heat formed in deformed or induced during the motion from the cuboid or cube. Similarly, in the y direction we have a qy, and which rejects the heat qy plus dy. In the similar way, we have qx, which enters in the cuboid and leaves with the heat qz plus dz. The total heat consumed or transferred will be evaluated and calculated by the rate of heat conduction in the directions of x, y and z, and minus the rate of heat conduction at x plus dx, y plus dy and z plus dz. In the addition of rate of heat generation inside the element is implies or equal to the rate of energy content of the element. Let's start with the what is the meaning of the each term in the equation. What is heat generation? The first term in the above equation represents the rate of heat energy coming into the element of x, y and z planes. The second term represents the rate of heat energy coming out of the element at x plus dx, y plus dy and z plus dz plane. The third term represents the rate of heat generation inside the element. Let's discuss now what is the heat generation. A medium conducting heat energy may involve the conversion of mechanical, electrical, nuclear or chemical energy into the heat energy. If we taking an example of when a resistance wire conducts electric current, it converts electrical energy into heat energy at the rate of I square R. That implies that the square of the current into the resistance. I is denoted for the current and the R represents the electric resistance. In the similar way, the heat is generated in an exothermic chemical reaction in the medium. The reaction may also be an endothermic reaction. In such a case, the heat generation term will become a negative quantity. Likewise, nuclear fission process in a nuclear reactor generates a large amount of heat in the fuel element. Now, the heat is also generated in nuclear fusion reaction. For the example, hydrogen atoms get fused into helium, making the sun a larger nuclear reactor. One thing is to be noted that the heat generation in a volumetric phenomenon, this means that the heat generation occurs throughout the body of the medium. For this reason, the rate of heat generation in medium is equal to specified per unit volume. That will the mass, that will be the watt per meter cube. The rate of heat generation may vary with respect to time as well as the position within the medium. When variation with respect to position, that x, y and z is known, we can calculate the total rate of heat generation in a medium of volume V. In this equation, you can see that we have a E generated, energy generated is equal to the integral of energy generated into the change of volume. This shows that the total generation of the heat or transferring of heat with respect to the volume, it may be differ. Depending upon the variation of the volume, the generated heat may also be varied. If the rate of heat generation is uniform throughout the medium, then we can say that the energy generated is equal to the energy generated into the volume. Now comes with the fourth term, it represents the rate of change of energy content of the mass contained in the element. Let's start with our derivation of the heat conduction equation. In general, the heat conduction throughout a medium is multidimensional, that is, heat transfer by the conduction happens in all the three directions, that is x, y and z axis or the directions. In some cases, the heat conduction in one particular direction is much higher than in other directions. In such cases, we approximate the heat transfer problem as being one dimensional neglected heat conduction in other direction. Now we will develop the governing differential equation, the heat conduction. Consider the differential element of the volume dV with the direction of dx, dy and dz in the Cartesian coordinate system, and the equation will be the heat transferred from the outward to x-axis minus the heat rejected from the system, that is a qx plus dx. In the similar way, in the direction of y, the heat entered from the y plane, that will be the qy, minus the heat rejected from the y plane, that will be the qy plus dy. And similarly in the z direction, plus energy or heat generated is equal to the whole equal to the change of energy by the with respect to time. Now the rate of heat generated within the element is that total heat generated is equal to the heat generated in the plane of dx, dy and dz is equal to the heat generation into the change of volume. The variation of the volume may changes the heat generated values in the system. The rate of change of energy content of the element. When we talking about the change of energy with respect to time, that is the change of rho into volume into C into T with respect to total time, where the P dV Ct is equal to the capital E. The equation PV dC dt is equal to the term that is MC dt. That says that the mass into the change of constant volume into the change of temperature, that is equal to the energy. From that equation we are taking this reference and putting it in its equation, and we will get that change of energy from in the plane of x direction or x plane, that is the qx minus qx plus dx, which is equal to the negative sign of partial differentiation, that generally known as curl qx by the curl x into the dx. If we are putting the value of qx in the equation, and we will get that minus curl by curl dx is equal into minus k dv by dx into curl t by curl x into dx. Here curl capital T represents the temperature and small t represents the time period. The change from the plane in entering and the exit is equal to the curl k curl t by curl x by curl x into dz into dx, where dy dz and dx is equal to the volume. And in the similar way we will discuss that the values in the x direction, taking the reference, we have the volume we have the equation for the y plane, that is the qy minus qy plus dy is equal to curl t by curl y upon curl y into the dx, dz and dy. In the similar way we have the same equation for the z plane, that is the qz minus qz plus dz is equal to the curl k curl t by curl z with respect to curl z into the dx, dy and dz. These are the equation for the direction or the plane, that is for the x direction and y direction and the as well as for the z direction. we will consider the we are considering in the 3 dimensions. That's why we are taking the 3 parameters for that. If we're talking about the linear equation or the single quantity, we have to mention only one plane, that could be the x, y or any z. But right now in the 3 dimensions we are taking the three of them and adding them, by which we are able to understand the how much quantity and the how much heat is involved and passed through the cuboid and the cube surface. As now from the above equation we added the whole equation, that the curl into k into curl t by curl x with respect to curl x plus curl k curl t by curl y with respect to curl y plus curl t by curl z upon curl z. This is for the x, y and z respectively, plus the heat induced in the body or the system added into this all the contents of all the components of the equation or the plane, and the summation of all this direction and the heat induced will be the rho c curl t by curl small t. This equation is the heat conduction equation in the Cartesian coordinates, and we can evaluate the all the heat induced, heat generated or heat transferred from the system by the help of this equation. This is the standard equation for the heat conduction in Cartesian coordinate. If we add more over it and taking some special cases in the for this equation, and we will get the several new equations by which we are able to configure, and putting the if we putting the values in that, we will get a straightforward answer. We don't have to complicate all over the equation. For the special case, first we have a steady state. Steady state means there is no movement. The steady state refers to stable condition that does not change over time, and time variation of the temperature is 0. By the help of this equation and taking the reference from the first, you can see the change of temperature with respect to time, that will become a 0 at the steady state. It means the rho c curl t by curl t will be the 0, and the equation will form where right hand side that rho c curl t by curl t will be 0. This case is for the steady state in which no movement takes place with respect to time. Next we have a uniform property. If the material is homogeneous and isentropic, the thermal conductivity of the material would be constant. If we're talking that, what do you mean by the term homogeneous and the isentropic material? The term homogeneous means the value of physical property of a material do not vary with the position or within the body of the material. For the example, the value of thermal conductivity at position x1, y1 and z1 will be the same at the position of x2, y2 and z2. For the isentropic, the term isentropic means the value of physical property at the point difference direction will be the same. This is to say that kx is equal to the ky, and that is also equal to the kz at that point, in which we are able to understand that the value of thermal coefficient is same for all the parameters. Then the equation will be formed, that will be the curl square double differentiation of the temperature in the x direction plus double differentiation of the temperature in y direction, and the double differentiation with respect to z direction plus heat induced or the generated with respect to thermal coefficient with is it's equal to the 0. That shows that the change of temperature or differentiating the double differentiating of the temperature is equal to the negative term of heat generated with respect to thermal coefficient. This equation is also known as Poisson equation. Let's discuss the next case, that is no heat generation. When there is no heat generated inside the element, then the differential heat conduction will become the 0. It means from the last equation, the heat generated with respect upon the thermal conductivity is also be 0. Then we have a small equation, that is the double differentiation of temperature with respect to x plus double differentiation of temperature with respect to y plus double differentiation of temperature with respect to z, and the summation of all the directions will equal to the 0, where we will implies and we will say in the shorter way that the change of temperature, the double differentiation of the temperature will be 0. The next and this is our Laplace equation. The last one is our last but not the least, the one directional form of equation, in which we don't have the y or the x direction, or similarly we have we will take the y direction and we don't have x and z direction, and could be the z direction in which we are neglecting the y and x direction as well. If the heat conduction in any one direction is in dominance over heat conduction in other direction, then the complete equation get reduced in the form of double differentiation of the temperature with respect to the any x, y or z direction is equal to the form 0. It means the right now we are taking the example of x direction. It means the x, y and the z direction values are minor over the heat produced by the x direction. That's why we are neglecting the y and the z plane and showing the values of x plane. Thank you for watching this video. In the next video we will continue with the another derivations, and today by this lecture we are able to understand the heat conducted by the three-dimensional object and the in the Cartesian coordinate. It could be a cylindrical coordinate, or in the polar coordinate, and the as well as the spherical coordinate. We will study those equations in further lecture. For today I am signing off and saying thank you, and stay tuned for the next videos, and that will be uploaded in the channel soon. Thank you.